Hello and welcome to my video, lesson 8.1, solving systems graphically. So here we can see that we have a few different systems of equations. We have a bunch of ones that start off nice and easy with two linear equations right here. So that's a system. We also have another system over here with a linear and a quadratic. Here we have two quadratics. And finally we have two quadratics that are mixed up. Okay, so progressively getting harder. So let's take a look at the first one here and see if we can solve this question. The first one is actually a question that would be right in line with Math 10C. And so it's actually hopefully not too difficult. You're going to plug it in your calculator like this, just as shown, and then you're going to press graph. And so you should, if you press zoom 6, have a graph that looks something like this. Then you're going to go second, calc, intersect, and you just want to kind of go roughly to the point where it's going to intersect, and then you just press guess, so enter, 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 and it gives us 2 points there. Notice that they are not beautiful, nice points. If you want nice points, then generally speaking, those are going to be the algebraic systems, or ones that you can answer algebraically. I just made these questions very quickly, so they're not going to be very nice points. They're just decimal answers. So we have x is, I'm going to round it off right here to the thousandths place, and y is this to the thousandths place. So again, you just input your two lines, making sure you have y equals, that's the key, and then find the intersect. That's it. That's not bad. Now, there are a few things to notice when you're solving graphically. If you can kind of imagine, there are possible situations, and I'm hoping I didn't accidentally screw that up with any of these, but if I did, you guys will be the first to know, and you'll see right away why that is. So anyways, if you have two lines, and they are not parallel, they will intersect at some point, right? But if you have two lines that are exactly parallel, then they'll never intersect, and you'll never have any solutions. So then you'd say no real solutions if they never intersect. This can also hold true for a linear and a quadratic, where you can have literally only one solution. You can kind of imagine if you have the, whoops, I guess not going that way. If you have the quadratic going like this, you can imagine that it could only touch in one spot, or you can imagine that most of the time your quadratic is going to touch in two spots, or sometimes your quadratic may only touch never, in no spots, right? Depending on the quadratic. Okay, and same thing if there's two quadratics, you're not really entirely sure if they are never going to touch, like these two, if they're going to exactly touch in one spot, like these two right here, this spot here, if they're touching, okay, or if they could be touching in two spots, like this one, right? So you can imagine that there's different amounts of solutions depending on the graphs that you have. Okay, with all that said, let's get back to and start a Math 20-1 level question. So we're going to plug in this value, 2x plus 3. So the important part is that we have y equals 2x plus 3. If you don't have that, you need to rearrange, which we're going to see in the last question, until you have that. Otherwise, it will not work. So anyways, we're plugging in the second set now. So x squared minus 2x plus 4. So now you're going to graph that. And my window is not quite tall enough, so I need to just get a little bit higher. Whoops, maybe go 15. There you go. And now I can see both of the different solutions. There's one near the y-axis at like y equals like 3.5 or something, and then the other one is somewhere around the y equals 10-ish mark. So let's solve for both of those. Well, we're just going to have to get the intersect at both points. So roughly there. And this is where it's really important that you guess so that it knows which point you're looking for. So the first set is 0.268, comma, 3.536, bracket. And the second point is, well, whoopsies, we have to go back to, oh no, now what have I done? There you go. My bad, I accidentally nicked the wrong button. Okay, going back and finding the intersect, but now of the second point, the second intersect. So we have 3.732, comma, 10.464. Okay, and questions will always ask you for a certain number of decimal places to round to so that you don't have to kind of guess on your own. Although most of the time when it's assignment or exam questions, they're going to be exact answers and not decimal answers. That way you can do it without a calculator. So most of the time you can do it with or without a calculator. Okay, looking at our last easy question, and when I say easy, I mean easy for 20-1 level question. So x squared plus 3x minus 2. Going to the next set, we have x squared minus x plus 5. We're going to graph those two and see where they line up. It's hard to tell for sure, but it looks like to me like there's only one intersection. So let's go down and solve for that one intersection by going second function calc, intersect, and guessing roughly that point. So here we have the point 1.75, comma 6.3125. There you go. And because it was an exact answer, I wanted to include all of the decimals. All right, now we have our final and most difficult question here. Because we don't have y equals something, right? We're missing that. We need to rearrange. So let's take this first equation and rearrange. So first of all, actually, let's make it look like math. There you go. Okay, so we're going to take this first equation and rearrange. So let's rewrite that out just so it's nice and clear exactly what we're doing. Very methodical, very step by step. We want to get the y by itself. So we're going to subtract by 4x on the left and subtract by 4x on the right, and sorry, 4x squared. And so on the left side it goes to 0, so we can ignore that. So now we're only left with 2y. On the right side we have well, I may as well write it the same way. 12 minus 4x squared. Sorry about the noise in the background. Someone outside is doing something. Oy, oy, oy. Hopefully you can still hear me. I'm going to just talk a little bit louder here. Wow, that's terrible. Okay, so we're dividing by 2 to get the y by itself. We're going to do it to one side, then we have to do it to the other. And actually, speaking of which, let me use my other color pen so that it's very clear that we're moving that over. Okay, so if we're multiplying and dividing by the same number, it goes to 1. So it's just 1y or just y. And then on the right-hand side, 12 divided by 2 is 6, minus 4 divided by 2 is 2x squared. Woo! There you go. We've nailed our first question down. So now we're going to write our second equation. And we want to get y by itself again. So just writing it out as before. And now we're going to try to get y by itself by moving the 6x over, subtracting by 6x on both sides to do so. All right, so now we're left with negative 3y equals 9x squared minus 6x minus 15. I like to write it that way just because it makes more sense to me. If I rearrange the order, it doesn't really matter because we're plugging in our calculator, so it doesn't much matter anyway. But anyways, we're going to divide by negative 3 on all sides so that we're left with y equals negative 3x squared plus 2x plus 5. There you go. So now we have two equations. Let's see if I can just highlight those two equations that we're going to plug into our calculators. So x minus 2x squared, our second equation is negative 3x squared plus 2x plus 5. And so now we can plug those two in, and yoicks, 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 it's hard to tell if those two are 1, 2, or 0 intersect. So what we're going to do is we're going to just use the zoom in function. If you've never used that before, it's just zoom and then find the zoom in one. And I'm going to just zoom in to where I think they could be touching. Oh man, still hard to tell. So let's zoom in again. Zoom 2. And I'm kind of going into the middle of what I want to see. Oy, oy, oy. I think that they're just barely touching in one spot. So would you look at that? I think that we only have one intersect. I'm going to try this on the left and see if it gets it. Yeah, it looks like it's getting it in the middle. So looks like we only have one intersect, and it's 1, 4. But just in case, we can always try, if we're not sure, just look for an intersect further to the right. And if it is there, it should show up, right? So you can guess on the right and see if it gets it. It still gets the same spot. So there's only one intersect. But wow, that's a funky looking graph where they're just barely touching, hey? All right, so I hope that this video helps you understand how to solve systems graphically using a graphing calculator. And I hope it helps you understand that there can be 1 or 2 or no real solutions. And your graphs will let you see that right away, assuming it's a little bit more clear than this one. But you can also do this all algebraically, which you will see in 8.2. Hope this video helped you, and good luck.